I'll get started then. I'm at a disadvantage here just in terms of the way we had to share this. The slide deck is really large just because of the content, so I'm not able to see questions and answers. So if you want to hold them or even put them in the chat, basically I'll try to finish up speaking here around 1:45, and then we can have a discussion and some Q&A. So welcome everybody. Thank you for attending. My name's Colin Gillis. I'm one of the owners at a local company here in Halifax called Smarter Spaces. We've been around since about 2016, and I've been an entrepreneur since 2005. We're focused in geospatial and emergency services, where we really work with pretty much anybody who's involved with buildings or owns a building or works on buildings. So we provide easy access to the most up-to-date, accurate building information related to geospatial and emergency. So really, at the end of the day, what we do for our clients, which would include engineers like the audience here today, architects, building owners, is save them a lot of time and money in terms of schedule and budget. So today we're here really though to talk educate and awareness. So I'm going to start at a basic level because I really don't know with the number of people on here what the level of knowledge is around geospatial technology and some of the things it can do. So with that said, it may be a bit basic for some of you at the start, but we'll get into some more complicated things here as we go. So I'm going to cover off some basics, what a point cloud is, difference between some different types of Lidar, some of the other technologies around cameras and 3D virtual tours, and then really it's all about the data. What data are you collecting, and then understanding how you're going to use it. Starting at the basics, what is a point cloud? So this technology is quickly evolved. We got into the market in 2016 with our first purchase of a mobile SLAM technology, Lidar. So simultaneous location and mapping is that acronym, but this is a building in downtown Halifax, and really what a point cloud is millions and millions of dots. So each dot has an X, Y, and Z, and provides an accurate location. So in these images I've shared here today, it's just a good example. The top left really is just a regular normal JPEG, and the right is a point cloud. So that's the raw point cloud data that any 3D scanning technology will produce or output. Below is kind of the scaled back version of the whole floor. So it just gives you an idea there with the arrow pointing down the hallway as to what you're seeing. So again, raw point cloud data can be useful if you're able to use some of the technology out there and software. One of the most common ones is Cloud Compare, which is a free software. You can go in and manipulate and play with point clouds as much as you want and measure things. But it's not a common software. A lot of people don't know how to use it. So a lot of times this is converted into either AutoCAD or Revit files. So that's your basic point cloud. I guess just some more examples. There's a picture of the mobile LiDAR. So that's a GeoSLAM product out of the UK. They were one of the first to market, and we brought it to Canada. It originally started, I think, focused on mining, but it's really moved into what they call anywhere mapping. So this image is just one of my favorite images we did early on of the Halifax Armory, and it just gives you a good example of kind of level of detail you can get. And this scanner shoots about 44,000 points a second, and its accuracy is roughly about 1 to 3 centimeters. So it's fairly different from some of the terrestrial technology, which I'll talk about, but the mobile allows you to get in and out of places very quickly, works inside, outside, but it does not do photo overlays. So the imagery you're seeing here is the imagery you got. So when you actually get into drawing, you can get lost in some of the point clouds if you're trying to redraw them into softwares like Autodesk or Revit. So in some cases we'll accompany this with photos or 360 imagery, but I'll tell you a bit more about the difference as we look at some of the other technologies as well. So terrestrial is the other common. It's actually caught up a lot, really, in the last 2 years to the mobile lidar. The mobile lidar really took off because it was so quick and efficient. The images here is one is a Faro and the other is the Leica RTC. Even within these two devices, they both have their time and place for use in different projects, but at a very high level, it's a good example just to share how they work differently. The Faro is, in this image, is a little bit older, and every time you use it, you got to put up targets, which are those round balls you would see sometimes on construction sites or even some people doing some surveying outside. And that is how it locates itself. So still works very well. It takes a little bit longer, but the RTC is probably one of the newest units out there. It does some pretty amazing stuff that's pretty impressive, where it doesn't need those targets. It's able to auto recognize, and it's getting a lot of traction in the industry and being used by a lot of people. This image, now some of these may play choppy. Beth and I played with this, so I'm not 100% sure how well this is playing for you, but I'll talk over it as it plays. I just thought it was a good example. It's a Grand Parade outside and then into the World Trade and Convention Center here in Halifax. So this gives you a good example on the terrestrial LiDAR side of a colorized point cloud. So this is actually taking imagery as well, which would be one of the differences between mobile SLAM technology and the terrestrial. And I'd like to point this out just in terms of if you're sitting back at your desk, often it is a lot easier to be able to reference something that's a colorized point cloud that has real imagery in it to figure out what you're looking at. Again, advantages and disadvantages. When you crank the imagery up on the terrestrial scanners, sometimes it can take as long as 12 or even 14 minutes, depending on the exact settings for you to be able to do one scan. And in a large building like the convention center, if you were to do the whole thing, that could take a long time. So you really got to determine what you're going to use the data for, which is kind of part of what I'm trying to educate people on here today. So one of the other major differences with the terrestrial versus a mobile is, I'd mentioned earlier with the Armory example that you're looking at, about 1 to 3 centimeters in a level of accuracy. Now, when you get into the RTCs and the Faros, you're getting closer to 1 to 3 millimeters. So it just depends on what you're doing for your project and the level of accuracy you need would dictate the technology you choose. The output, this is a project we did for the federal government, the Dominion building in downtown Halifax. So this would be the extreme output, I guess, of raw point cloud data, and the reason that people use them today at the end of the day is producing accurate existing condition models before you start a major renovation is often the reason for doing this. So in this case, this was a combination of mobile and terrestrial, so we were able to capture everything above and below ceiling and model it out. So this becomes a lot easier when you're dealing with, in this case, it was just a business office, so we were able to pop a lot of the ceilings. But if you get into hospitals and other buildings where infectious control is involved, it can get a lot more complicated, a lot harder to access the ceiling space. Jumping into another type of technology that's in the geospatial field that I kind of want to make people aware of is this one here is the Matterport Scanner. I think this one, yeah, this will play. If it's not choppy, it's just scanning, in this case, a mechanical room. So this is actually a scanner. It's called the Matterport. I'm guessing that some of you have heard of it. It came out of the US residential housing market originally, but they've been around for probably 4 or 5 years now, and they've got devices all over the world. So they've been really successful at kind of bringing this to the forefront and using the term 3D virtual tours. So in this case, if you were in the model itself on your desktop or on your laptop at home, you would be able to walk all through this electrical room, mechanical room, and even zoom in and read things. We even in working with engineers on different projects, we've done probably about 50 NSLCs across the province of Nova Scotia. And we even get into the detail of opening electrical panels so that if the engineers or designers are sitting at their desks, they can even zoom in and read the label. So some of the advantages to this are it's quick, it's easy to use. It does also produce raw point cloud data because it is a scanner, but we've done some projects working closely with some of our engineering partners, and really we both have concluded that the point cloud data that comes out of this, because it's generated not by Lidar, but photogrammetry, really does not give you the level of accuracy. The point cloud tends to be really dense, meaning that you really have a hard time defining where the lines are. And it just becomes difficult to measure from, although it is unique in the fact that you can, in the software itself, if you go into the user friendly open environment where you're jumping around the tour, there is a measurement tool, and depending on where you're at in the tour, it can be accurate. I guess you can't see it in this example here, I don't think, but in an actual tour itself, if we were to open one up, it's got circle icons on the floor that show you where you're at. So if you're measuring something using their measurement tool that's relatively close to you, it can be fairly accurate, but the further you get away, the less accurate that is. So our general conclusion is we tend to not use this tool to measure from. The other limitations on this, we actually own a Matterport ourselves, so we do use them, but the other limitations on this are it's hosted on US Amazon servers, and they own the source data. So you actually don't own the 360 panoramic images in this. It's stored on their servers. And I don't think they're going anywhere, but we always like to make people aware of that. And we've had some of our own clients express worry around that, say 10 years from now, if you're doing something that you want to save long-term, are they still going to be here? So that will lead me into our next discussion, just on another solution that works similarly, but has some other advantages that the Matterport doesn't. The other limitation I point out on the Matterport is you have to scan every 5 to 8 feet. So in doing every 5 to 8 feet, it can become tedious, and if you have a massive warehouse, it can take a long time to do things because you can't just randomly jump around. So that's drew us, I guess, in the direction of developing our own solution. So we don't create technology like cameras, but there's a ton of them out there now, and there's more and more on the market every day. I just shared an image here of, I think the middle one is the Insta360, and the other one is a GoPro, which you often see athletes and outdoors people using, but they both do 360 images and 360 video. So this has really become much more popular in the last couple of years. And so a 360 video is really interesting. You don't see a whole lot of them in market yet, but they're starting to get more popular. I think over the next year, you're going to see more of them used in professional campaigns for tourism and things like that, where you can actually, as a good example, we're working on the Blue Nose right now for a 3D virtual tour, the Blue Nose 2. And there's some 360 video shot on that from the front of the boat where you can actually look around while the boat's moving. So it's a little complicated to explain, but if you search it out, you can see some samples online. And then they both, of course, do the static 360 views, which in the previous example, the Matterport Scanner is doing the same type of thing, but it's using a scanner which produces the point cloud I talked about. But again, it's not as accurate for measurement. But in the case of these cameras, you're not measuring off of these either. These are just photogrammetry models that are used really for visual effect. So where this drove us as a company at Smarter Spaces was to develop our own custom solution. So I think this is pretty unique. I haven't seen anything close to it in the market, but what we've managed to do then, taking in feedback from our clients, whether it be government on privacy concerns or even private developers who want to make sure that they have their data forever, is developing a custom platform where instead of just having imagery you can jump around on, as in this example on the left, you can see the floor plan. So what we've begun doing, we call it BAM, Building Accuracy Modeling. So as buildings are being built, we're getting inserted into the construction schedule, and we're capturing everything above and below ceiling before it gets sealed up. So we've done several buildings in Halifax. We've done a couple hospitals. This is actually a private developer, and the example here, you can see all the circles here on the left are everywhere that we took an image. So basically you're able to, in this model, jump to any of those circles, and you actually even have a radar that gives you the angle of direction. So when the team is in the field collecting things, we tend to make sure that we're using a compass and direction, so that when these are loaded in after the fact, that they're able to connect and point in the right direction. You also have the ability to jump between floors, levels, very customizable, and allows a lot of interesting things. I wasn't sure how well, I've got a sample video here that I'll play in a second. I wasn't sure how well it would play, so I included some static images here that I'll maybe talk to first. This is a great example of what we call BAM. So you can see everything here. You can see the circles here in this quick example of where we took other images from. So if you can visualize yourself 10 years from now doing a renovation or trying to find something in the walls, you basically can pull up the floor plan that we just looked at, and then you can figure out where you want to go. Take it on your mobile phone, tablet, works on both, and go down and kind of look at what's behind the walls. Also kind of use cases for maintenance and operations, reducing costs. If you ever have a leak in the wall or you don't know where a shutoff is, instead of ripping a whole wall apart, you'll be able to go back and look at this model. And it's pretty interesting too, in the fact that you can capture the whole building and have, as the tabs up top kind of demonstrate, the ability to jump between floors, rooms, suites, and even to the level of if you're a developer and you have many projects in, say, Nova Scotia or even across the country, we can incorporate that all into one model, that you could have access to all your buildings in one place. So let's see, I think this is my video. So it might be a bit choppy on your end. So this is just a little video we recorded the other day just to give people an idea. So you can see he's clicking on circles and you can jump around to the model wherever you want to go. As I mentioned too, you can also pull the tabs open and go directly to a certain location. So kind of panning through different wall views here. And it just as a side note, I just kind of saw some writing on one of the posts there, and we've recently just did one of these for Habitat for Humanity, and it was a lot of fun. Some of the volunteers signed the posts, and we were able to provide that to them, and able to give that kind of as a thank you to their volunteers who were able to help out. Kind of frozen here at the end too, you can kind of see into the electrical panel. We also have the ability to zoom in further than that, so that's kind of interesting. Second video here, actually this same video playing. Let's jump to the next one here. So this is a larger site that we did. This is going to play here. Let's just see. Yeah, I think this is a bit choppy, but in this video, if it's working on the shared link here, the map up on the right, you're actually going to see him moving around and the radar changing direction. So in this case, we're up in the ceiling. So this is pretty unique and fascinating. I think a lot of the engineering folks on here will find this interesting, that we're able to capture everything in the ceiling. And in this case, you can even identify major infrastructure and follow it through the building to see what things look like. I'll let this play through again, just again, not sure how easy it is to see. So in this case, I think we were trying to demonstrate you can follow a run of pipe through the whole building. So we found the run again, and then you can look around and even zoom in if you're trying to read writing on different things. Even in some other examples of some more complicated infrastructure in some of the hospital projects we've done, you can zoom in on electrical boxes and follow numbers and drawings through the whole infrastructure of the ceiling. So it's really an interesting way to look at things now. You can also do above and below ceiling, so it's not demonstrated It's not demonstrated in this model right here. Like I said, it's a little hard to share things through Zoom. But you're able to change the settings in these models to say below ceiling, and then you can see what's below as well, which makes it some interesting use cases. These are just some images. This, again, this one is going back to some of the mobile Lidar we did, but same idea, it's above ceiling. So this was one of our industrial clients. So they had a 16-foot plenty of room to get up there. So in this case, we did Lidar in addition to imagery. So in this case, you can get up there and measure. And in terms of what we modeled out, we kept it pretty basic in this example to the major infrastructure. We're not engineers. We're not experts in mechanical. So what we've learned on a couple of these projects is it can eat up a lot of time, and our discussions and experience, and I'd love to hear back from anybody if they have any insight or questions. But our experience has been the value kind of in the model I just reviewed with all the imagery is really helpful, versus it did take an extreme amount of time to model out. In this case, it was simple, but some of the other projects we tried, it does take a lot of time to model out. So we're just trying to figure out, again, in terms of awareness and education, the data that's required by design teams and engineers to see, in some cases, maybe it is worth trying to get LiDAR data, and in other cases, the imagery is probably more important. Again, I showed this slide already, but it's just showing the extent of what can be modeled out in Revit, and that's where we kind of work with our clients to determine what they're trying to do. So we have a couple of engineering firms we're working with today where they are just using the 3D virtual tour with the imagery, and they're doing their new design work without having to model anything out. It's more or less for them. The value was in being able to see what was in the ceiling above. There's some unique things that we get into that would fall outside of kind of some of the infrastructure building stuff that we talked about. I just figured, not knowing what engineers were on this call, that I would introduce a couple of them. This is a salt dome. So this is in Halifax. So we've been working with the province here for numerous years, where we have actually gone in and you take your mobile LiDAR and you scan the dome itself. And then from there, we would have modeled it once in Revit. And then I believe, I'm not the technical expert on this side of it, but I believe we then are able to go in, once we go in with our mobile LiDAR, again, this is actually walking up and around the salt within the dome. And it's interesting sometimes if it's too high, safety-wise, we'll get them to cut it down. But once you go in there, you scan the dome that first time, and then we then we go in after that, and we scan just the salt. So then we're able to take it into, I believe that we take it into Civil 3D, and we're able to create a mesh and calculate the volume. So different use cases on that. Interestingly enough, we originally, when we first got our GeoSlam technology, we did look at different piles of aggregate and whether that was a viable option. But there really is there is much better drone solutions for that these days that can capture all that information much more quickly. The dome was an interesting, unique scenario where the drones just didn't have enough light, and really they were too expensive to mess around with. We tried a couple of trials, but it gives you kind of an indication of what you could do. We've talked a few times to developers too about the raw point cloud data. Just as more of them get used to it in terms of early design, you can look at things in terms of layout and topography. But again, it's not a survey drawing, but it sometimes gives you an indication of how you might position a building. The other interesting thing, we haven't really done much with it, but people have talked to us about fill in terms of projects where you're paying for tons of fill. I think of Dartmouth Crossing. If anybody's been out there, you know that there's tons and tons of dump trucks that dump fill in there. So that would be a good example where you could almost scan before and scan after, and just see, did you get the kind of volume you paid for? Some of the other interesting concepts we played with and have or are doing some research on. Same thing with concrete pours. You potentially could use the same kind of concept to calculate how much concrete volume you've received on a project. Tunnels, caves, confined spaces. Again, mining is where the GeoSlam technology originated out of the UK. I think some of the first purchasers here in Canada were mines. We've been primarily focused on buildings ourselves, so we haven't ventured that far into the mining, but I have seen cases in the UK where they're mounting the different mobile SLAM technology onto drones or even vehicles to go into mines and capture information. So I think there's some opportunities on that side. Again, just depending on what industry you're in, it has some interesting use cases. We have, outside of the caves, we've done some tunnels. The images on the bottom right are the spillway from Grand Falls, New Brunswick for NB Power. So every 3 or 4 years, they empty that out, and you're able to get in and they inspect it just to make sure that there's no major leaks and just see how it's doing. They also have done, I don't have an example here, but we did some Matterport imagery in there as well, just to do visual inspections afterwards. A little bit scary. It was fun to be in there, but if you go to the end of the line there, it kind of reminds me of one of the Die Hard movies where Bruce Willis is in the drains. There's water spraying everywhere, so it was a lot of fun, an interesting project to do. We've done a couple other similar things here in Nova Scotia where there's been underground tunnels used for whether it be spillways or energy projects. On the top right example here of infrastructure under Dalhousie. So Dalhousie, for those of you who are not familiar, they actually have tunnels that run all the way from the University Student Union Center on University up by the Rebecca Cone, all the way down to the old Daltech, which used to be called Tons. And there's infrastructure all through there. So it's interesting too, just in terms of safety and reducing the amount of time people have to go into confined spaces. It has some use cases there as well. And again, kind of deciding if you wanted to model, you can see in the top right there, the actual picture and the point cloud. So again, if you were comfortable with point cloud, you could go in and measure the point cloud to get measurements. To model that out would be time intensive and really, in our experience, not worth the time and the money that it would take to model out the existing conditions on mechanical. Now, that's changing in the US. If you start looking at manufacturing in large plants, we have a partner company in the US we do a lot of work with called Gillis, and they do whole manufacturing plants where they are modeling everything out. The other thing we're keeping our eye on is the kind of autonomous software where it's getting better at taking a raw point cloud data and automatically drawing it in technology such as Revit, but they still have a long way to go. We've done some samples where there's just still a lot of things that pop up that give the autonomous software some issues. So we're going to keep our eye on that. It always helps to know what's going on and what's the latest in the market. So maybe a little quicker than I had thought. It's hard to tell sometimes on how long presentation will take, but I'm going to unshare here now, and I should be able to then see some questions here. So just catching up here, as I had mentioned when I was inside the PowerPoint there, I wasn't able to see questions. Hopefully everybody got their sound straightened away. I'm just looking here, questions. Screen freezing. I suspected the screen would freeze, and so I tried to talk over and have some images there. Hopefully I didn't freeze up on everybody. So I don't know if I want to open it up there to discussions. Anybody have any questions or comments that you want to have a discussion on? Yeah, someone's just asking if I have more detailed PowerPoint. I do have some more detailed PowerPoints that have a bit more information, which I can put together for Beth and share if people want more information. Also, feel free to reach out to me directly if you have any questions. I don't mind. I'm not the tech expert on everything. I got a good wrap on things, but we also have a couple really good technical people if there's more technical questions. I see a couple people are typing here. We'll see. I guess maybe while I'm waiting for some questions here, the other thing I wasn't sure if I would touch on, depending on time, is just the topic of BIM, so building information modeling. It's a really overused term, but it's coming like a train, I like to say. Some of the federal government and even some of the universities now in Canada are moving into BIM. So it's really BIM is more about a process. It's not really a specific thing, but building information modeling is really using 3D models. And some people like to use the word digital twins to convert real life situations or buildings into virtual models where at the high end of it, I kind of like to use the car analogy. You got Cadillacs where you, if you're tied into the Internet of Things and different technologies that can measure even water pressure in pipes, like you can get to that level that you can get automatic readings off things down to a basic, what I would say, a Kia or a Hyundai, where you're basically just in your basic 2 or 3D model with not a lot of information. And then kind of where we hit the ground with our clients is in that middle ground where you're able to capture everything in 3D and model it out. And it's really up to discussions with you and your partners on how much detail and where they are in terms of the tech savviness they have and the ability to use the Internet of Things to collect data. So there's a few questions here. So let me jump over here and see if I can give some answers.
Colin, I put some in the private chat for you too.
Okay. Okay. Can you see the bottom of a lake with an underwater 3D scanning camera? Yes, actually, oil and gas, they use a lot of technology to do so. So I believe a local company, Kraken here, creates manned vehicles, and that's some of the information they're into. What's really fascinating with underwater stuff is a point cloud is a point cloud. So if you're good with point clouds, it really doesn't matter if it's a mine, a building, or underwater. You can work with them. So there's some fascinating stuff going on, especially in Halifax, where we're the ocean cluster. Not an expert in underwater, but it definitely is happening. Another question here about, jumping around here, thermal imaging, I believe. Let me jump back up here. Thermal imaging is possible instead of JPEG images. We haven't done a lot of it, but there's definitely thermal imagery available. I have a company here that we kind of direct some of that work to here in Halifax, that you're able to go in with thermal cameras and do all of the heat loss and energy calculations. Now, we've developed a platform for interaction, which you would be able to do that as well. We haven't done it yet, but it's a great question. But yeah, we could set up, if we took the thermal images, to act in the same way as the normal images. Can you paste a Revit 3D model into one of the point cloud models? So it really works the opposite way. You pull the point cloud into Revit, so it creates massive files, but that is kind of at the very basic level. What we were doing is you take the point cloud in, and at its most simplistic level, you're tracing the point cloud in. In our case, we use Revit, so definitely possible. And then generally, what we do is we'll save a version of that massive data, and we'll take the point cloud data out, and then to our clients, we'll provide the Revit file and PDFs or any of the Revit files are an Autodesk product that can be saved into an AutoCAD file as well. The direction we've chosen is we do everything in Revit because it can be converted to Autodesk AutoCAD, so it's easier that way versus trying to go back and forth. So we can't provide either. So Peter's question here, can you take measurements from image data, such as measuring the length of a distance between pipes? So in the Matterport solution, the scanner I talked about, yes, you can. It's got a measurement tool. And again, that would be where I talked about the level of accuracy coming out of photogrammetry is not as reliable. The closer the image is to your center, you're going to have a circle that you're standing on in the Matterport scans. The closer your measurement is to you, the more accurate it will be. But we kind of say your accuracy there is going to be anywhere from 3 to 10 centimeters. So you just have to be aware of what you're looking at. Frank, thermal possible depending on the Lidar system you use. If that's a question, but yes, to my point earlier, thermal can be done. Julian there, about calculating how much water's in it. Haven't tried that, but I suspect that you could. It would be an interesting side discussion. Mark has a question here. I've seen Matterport used with a lot of residential real estate, handy during COVID. Absolutely, that's actually where it came out of, Mark, is it came out of the U.S. residential market, and COVID has sped it up 1,000%. So I think you see most homes now having those tours. So there's a lot of cameras around, not just Canada, around the world. Matterport has really taken off pre-COVID, but even more so now. Question from Adam. Adam here, has your company done any LiDAR, other tech for creating point clouds of very tight machinery spaces? Can they be used for measurement and any issues found? Yeah, we have. We've done some industrial projects, Adam, where we've gone into power plants and we've done precise measurements. That's where you're going to want to get a terrestrial scanner, whether it be a Ferro product, an RTC, a Tremble. There's all kinds of different solutions out there, but you can get some really high-end accuracy out of them where you start to talk about points per second is what you'll hear people saying. As I mentioned earlier, the mobile SLAM technology is about 44,000 points a second, but you can get some of your terrestrial that are 3 million, 5 million, 8 million points a second, which increases your level of accuracy. What really happens then, Adam, is that's where you bring the point cloud into, in our case, we use Revit software, and it's having a good mechanical tech who knows how to use the mechanical side to draw those things out. So we've done some of them, but that's where I was commenting that they're very time intensive. So it's really deciding what type of project it's going to be good for. And some of the projects we've done for engineering firms tend to be those more complicated, where it's a boiler room or something that's got to be replaced. That's all the questions there for now. I don't know if there's anything else anybody wanted to jump in with. A few people typing. We'll just see if anything else comes out here, Beth. If not, I'm a strong believer in meetings not being longer than they have to be, but I don't mind answering questions as long as people are here. So Mark's asked more question about BIM here. Do you offer as BIM managers on projects overseeing P&P, etc.? So we have a couple techs that are have the ability to do this, Mark, and it's really just taking off here in Nova Scotia and Atlantic Canada. I know there's some other places that are much further ahead. But we would definitely look at a BIM project, but have to understand it. That would be where, being frank, we're kind of ramping up and monitoring the industry to see how it goes, because one project can really take one BIM project manager on itself. They can become quite complicated, again, if you think of my car analogy in terms of how complicated you want to make the model.